So we always start our Glacier Overlook hikes with a stop here at Windy Ridge and a chance to talk about the 1980 eruption story from this iconic location. As many of you know, I used to be a park ranger here on the Mount St. Helens National Volcanic Monument, so imagine me standing here at age 20 in my little ranger uniform. It's a good time. So I get to relive my glory days by giving a little bit of my ranger talk for you all now. And as we think about the 1980 eruption, many of us have heard before, the only constant on Mount St. Helens is change. We have a constantly changing landscape, and we're going to get the chance to see those changes from before 1980 on the day of May 18th and everything that's happened since when we're out on the landscape today. So if we look back to time immemorial, of course, our native tribes in this area knew that Mount St. Helens was an active volcano. They had many stories and experiences of watching past eruptions. And as late as 1978, there was a study put out looking at all of the ash and eruptive deposits around Mount St. Helens. These scientists said Mount St. Helens is the youngest and most active volcano in the Cascade Range, and we predict it's likely to erupt before the year 2000. So we knew this was an active volcano. We knew there was stuff that could happen here. But of course, spring of 1980, things actually did start to happen. It started with earthquakes shaking the area, then small steam and ash eruptions, but the biggest sign of change on Mount St. Helens was visible right before our eyes, because Mount St. Helens actually began to grow. She began to inflate outwards to the north. The scientists noticed that this was happening. They saw some signs of deformation, so they sent their least favorite graduate student up to the slopes of Mount St. Helens with a big mirror, and they shined a laser at that mirror, and that was what they could use at that point to measure distance and measure change. And so they started measuring the mountain, and they found that it was moving 5 feet a day. 5 feet a day out to the north. Is anybody here about 5 feet tall? Everybody lives in the group? Sunshine, can you stand up for a second? So imagine growing one sunshine out to the north every single day. That is a big deal. That's a lot of change. And over the course of the couple of months prior to the May 18th, 1980 eruption, our mountain grew a total of 450 feet out to the north. And this is what we call, in very scientific terms, the bulge. The bulge was essentially a giant lava zit. Imagine crusty rock on the outside, ooey gooey magma on the inside, puffing out as the mountain is inflating like a balloon, puffing out to the north. So this is a big deal. This is pretty concerning. Scientists are keeping a close eye on the mountain. Of course, they're putting together all their theories of what might happen, trying to figure out the story of this place. But, you know, at that point, we hadn't gotten the chance to study all that many volcanoes, certainly not of this type, up close and personal. So we were doing our best to predict, but we also were just having to wait and see what was going on. And what was happening inside the mountain? Well, pressure was building inside the volcano. As that lava, as that magma is coming up from down deep, it's filling up the mountain. That pressure is getting greater and greater. All that gas pressure is building up inside the magma, and it's looking for a path of least resistance. And the scientists thought it would probably go upwards, because that's what volcanoes do. They erupt upwards. But we had that giant bulge on the north side of the mountain, creating plains of weakness. And so on May 18th, 1980, at 8:32 a.m., the mountain erupted outward. And thus began our May 18th, 1980 eruption. Now, Gary Rosenquist, many of us have heard his name. He was over at Bear Meadows, which we drove past on the way up to the 99 road today, and he was very, very lucky because he was able to photograph the events of May 18th, 1980, and then he was even more lucky to be able to get out of here in time. But he was photographing the mountain starting early that morning. He caught some of the very last photos of the mountain prior to the eruption. And then when that eruption began, it started with that bulge. Guides, I recommend bringing bigger versions of this photo than this, but this is what I found in the office. We had that bulge sliding off the north side of the mountain. And that bulge sliding off was like releasing the cork, or taking the cap off of our soda can. As that bulge came down, it created what we call the debris avalanche, or the largest landslide in recorded human history. Now, as the bulge came down, it released the cork, and it very quickly was followed by our lateral blast, this outwards, northwards explosion, this hot ash and rock-filled wind that blew through the landscape. Now, the debris avalanche was chugging down the mountain at about 150 miles an hour. The lateral blast was moving at about 300 miles an hour, so it very quickly overtook the debris avalanche, and it was the first thing to hit the landscape as it moved out across what we now call the blast zone. So as our lateral blast shot out from the mountain, moving upwards of 300 miles an hour, temperatures up to 700 degrees Fahrenheit, everything right in front of the mountain was utterly obliterated, smashed to smithereens, and actually picked up and carried with the lateral blast as it moved outwards. As the lateral blast started to get a little bit further away from the mountain, in places like around here at Windy Ridge, it had lost a little bit of its power. And so moving from what we call the tree removal zone, our first area, we get into the blowdown zone, where the trees were blown down, toppled like matchsticks, toppled onto the landscape. And if we look up here at the top of Windy Ridge, we can still see those blown down trees laying on the hillside today. Now the trees act like compass needles, pointing the direction that the blast moved as it went up and over the hills, swirled down around through the valleys. We see some really amazing formations of those blown down trees in some places, but they tell us a lot about what was going on inside the blast. Now, as the lateral blast continues out through the landscape, it's still picking up more and more debris. It's getting heavier and heavier and heavier. Eventually, it has too much. It can't hold it anymore. So it goes through a rapid weight loss program. That debris drops out, and now it's just a cloud of hot gas. As that cloud of hot gas rises through the forest, it singed the needles on the trees on that outer edge of the blast zone. Of course, for trees, the needles are like their lungs, and so if you burn the needles, the tree can't survive. So that left a narrow band on the outside edge of the blast zone that we call the standing dead zone. And that's what you drove through as you came around the blast edge viewpoint. You saw those standing dead trees, and they line the outside of the blast zone. Now, the furthest reaches of the blast zone are up to 17 miles away from the crater to the northwest of Mount St. Helens. The entire area of the blast zone is about 230 square miles, which is equivalent to the size of the city of Chicago. And all of that destruction happened within 3 minutes. The amount of time it takes me to make my morning coffee, the lateral blast was done. Now, that was a hugely impressive, insane event, but of course, the action was not done yet, because that debris avalanche, that giant, massive landslide, was still chugging down the mountain behind it, moving along at granny speed, 150 miles an hour. But it was doing a lot of damage on its own. Now, the debris avalanche was really the old summit of Mount St. Helens. And a lot of people, when they're standing here at Windy Ridge, they're trying to get a sense of what did Mount St. Helens look like from here before that debris avalanche? How did that all fit together? Well, a little trick we like to use is if you line up your hands with the sides of the mountain, Mount St. Helens is really a perfect cone before the eruption. So if you line, I encourage you to do this with me, give it a shot. If you line up your hands with the side of the mountain, you can get a sense for what that mountain looked like before 1980. A lot of folks called it the Mount Fuji of the Northwest because of that perfect cone. But of course, that cone came sliding down the mountain debris avalanche, and as it slid down, first it created this area that we can't see because the alders and willows are getting too tall. But normally we could see it from here at Windy Ridge. This is what we call the Pumice Plain, and the Pumice Plain is what we're going to be hiking across today before we head up into the crater. The Pumice Plain is on average about 150 feet deep in debris, in places up to 600 feet deep of debris from that debris avalanche. Now, as the debris avalanche continued on down, it slammed into Harry's Ridge, which we can see across the way there, and it was split into 2 lobes. The first lobe of it slammed into Spirit Lake. And I want you to imagine a sumo wrestler doing a cannonball into your bathtub. That's what this was like. So, as our debris avalanche slams into Spirit Lake, it fills in the bottom of the lake, and it sends a wall of water going up the far north side of the lake. Now, that hillside had just been hit by the debris avalanche. The trees had just been hit by the lateral blast. The trees had all just been blown down onto the hillside. That wall of water goes up 800 feet up the far walls, snatches all those trees, and pulls them back down onto the lake. And those trees, as we saw this morning, are still floating there today, and that's what creates the log mat that we still see on top of the lake, floats around and moves, and that's one of the reasons why we don't swim or boat in Spirit Lake, because those trees are still moving around there today. Now, when that water sloshed back down to the lake, though, of course, it was a different lake bed that it had left just a moment ago, because the bottom of the bed was filled up with that debris avalanche. So the lake is now quite a ways above where it used to be. It's only half as deep, but because it fills a wider portion of the basin, it's got about twice the surface area that it did before 1980. And everything that was on the lake shores prior to the eruption is now buried underneath the lake. Now we've got that one lobe of the debris avalanche that slammed into Spirit Lake, but the other lobe was diverted off of Harry's Ridge and headed down the Toutle River Valley. It traveled for 14 miles down the Toutle River Valley, When you're driving up that way, going up to the Science and Learning Center of Johnston Ridge, when you pass Elk Rock, that's about as far as the debris avalanche traveled. So a really, really, really long distance. Now, that debris avalanche sat there in the river valley for a while, but of course within the debris avalanche it had chunks of glacier, chunks of snow and ice that had pulled off the mountain that are now sitting there in these hot deposits. And over the course of the morning, they're starting to melt. And so right after noon, that debris avalanche started to move again in the form of a lahar. A lahar is a river of volcanic ash and mud and rock. Essentially think of a river of liquid concrete. Slow but sustained, moving, barreling its way down the Toutle River Valley, taking with it roads, cars, houses, bridges, logging camps, everything in its path, barreling all the way down to the Columbia River, where it cut off the shipping channel for 2 weeks, filling up the river with debris. So a hugely impactful event. That's the one that impacted our local communities in a really, really big way. So we've talked about our lateral blast, our debris avalanche, but of course, and our lahars. There were many lahars on May 18th, 1980. But of course, the event that most people remember the most is that iconic ash plume rising up into the sky. The ash plume began right after the start of the eruption, and within about 15 minutes, it had risen all the way 15 miles high into the atmosphere. And then it began to blow to the east, headed into eastern Washington, across the United States, and actually circled the globe within 15 days. So we used to say around here, you don't have to come to Washington, Washington will come to you. But that ash plume, even though it caused the least damage here on the landscape, it's the one that impacted people the most. Does anybody here remember getting ash falling on your houses or cars or anything like that? Yeah, so Jean was in the area at that time. This was the event that impacted people the most. It also had a huge amount of financial damage. The city of Yakima had to spend vast amounts of money, I'm forgetting the figure right now, I'm out of practice, had to spend vast amounts of money clearing out the sewage system from all the ash that got into it. We had to plow roads because ash doesn't melt away like snow does. We've heard stories of a microchip plant in Germany that had to shut down because the fine ash coming into their systems was messing with their microchips. So huge economic impacts and huge human impacts across the globe from that ash plume. The last event, one that we often kind of forget to talk about, were the pyroclastic flows. Pyroclastic flows are ground-hugging clouds of hot gas, ash, and rock that roil their way down the sides of the mountain. And those pyroclastic flows began on May 18th, and then we had events of pyroclastic flows throughout the summer of 1980. And those came down from our newly formed crater and essentially paved the Pumice Plain. So before, right after the debris avalanche, the entire Pumice Plain was what we call the hummocks, those big lumps and bumps that are chunks of the mountain. And the whole Pumice Plain would have looked like that. But over the day, over the coming weeks, as those pyroclastic flows came down, they filled in all the nooks and crannies and they smoothed out the Pumice Plain. So we can see all of these events still laid out here on the landscape, standing here at Windy Ridge. But as you all hike today, you're going to get the chance to see more change that happened. Of course, on Mount St. Helens, the only constant is change. When we were up hiking yesterday for the Into the Crater training hike, we saw there was a new canyon that was not there last year, that had eroded out from some rain or snow event this last winter. We see the landslide that happened over on State Route 504 just before Johnston Ridge. That landslide was within 1980 eruption deposits. The only constant in this place is change. And of course, one of the joys for us as staff and volunteers at Mount St. Helens is getting to share the stories of those change. Of course, the ecological stories of change, which you all are going to get to see a lot today. So I hope this gave a nice little introduction to some of these changes. And as you're out on the landscape today, point this stuff out, figure out where it is, put these stories together. One of the joys of Mount St. Helens is that we can understand these stories. We can read the story of this place written down on the landscape. So I hope you all have an awesome time out there on the mountain today, and keep reading the stories and keep sharing the stories. Thank you.